Good morning, dear students. Welcome to online class brought to you by CSE Department, Mohammadpur Kendriya College, Dhaka. You know that the whole world has been infected with the deadly virus corona. In this situation, government of Bangladesh has declared to close down all the educational institutions for your safety. But National University has taken a great initiative for you to bring the classroom in your home. First of all, I would like to introduce myself. I am S.M. Rokibuzzaman, Associate Professor, Department of Marketing, Mohammadpur Kendriya College, Dhaka. Dear students, this lecture has been designed for the student of BBA Honors, Department of Marketing, second year. So without wasting any time, let's start. Today, my target area is correlation analysis. You know, this is Business Statistics-1. As you know, this course designed for you in English version. You have to answer all the question in English form. So I have to conduct my class in English version. Correlation. What is correlation? Simply, correlation is the relationship between two or more variables. By correlation, we are able to find or determine the relationship between two or more variables. And with the help of statistical tools, when we are able to calculate the relationship between two or more variables, then we call it correlation analysis. This is the definition of correlation. Types of correlation. Dear students, there are two types of correlation we found in statistical history. First one is simple correlation, the relationship between two variables, not more than two. And multiple correlation means the relationship between more than two variables. For you, or as your syllabus, according to National University, we have to study simple correlation, that is relationship between two variables. Method of study correlation. What are the methods for study correlation? We have three methods for studying correlation. First one is scatter diagram. Second one is Kalperson's coefficient of correlation, and third one is Spearman's rank correlation coefficient. Sorry. Scatter diagram. Scatter diagram is a correlation represent between two variables without mathematical terms. That is, this is the graphical relationship of two variables. For example, look, model 1 and this is model 2. Model 1, variable x and variable y have different 5 variables: x, 10, 15, 20, 25, 30, and y, 5, 10, 15, 20, 25. Dear students, you can understand that variables x is increasing in the same direction. Also, y is increasing in the same direction. So, we can say this is a positive mode of correlation. I would like to inform you that correlation may be three types in different issue. For example, positive correlation, negative correlation, no correlation, or zero correlation. When we calculate the relationship, we find positive, either positive or negative, or no correlation. Positive correlation means when x increase, then y also increase. Another, model 2, when x decrease, y also decrease. this is called positive. X is moving, Y is following in the same direction. So both are positive. But model 3, X and Y, for example, 10, 15, 20, 25, 30 are, it is decreasing, but model 3, this is increasing situation, and on the other hand, this is decreasing situation. Positive, negative correlation and zero correlation. How can we draw a picture regarding scatter diagram? For example, this is y-axis, x-axis. Look, x bar and y bar, minimum value is 5, 0 to 5, 10, 15, 20 and 25, 5, 10, 15, 20 and 25, sorry, and y-axis again 5, 10, 15, 20, 25, finally 30. 5, 10, 15, 30, 15, 20, 25, 30, y bar. When x is 10, that is 10, y equal to 5. So this is the position of first variables. When considering 10, just denote y. Considering 10, just denote y. Considering 15, just denote 10. Same as, look, this is known as a scatter diagram. This graph emphasizes on there is a positive correlation between x and y. This trend, upward trend, means there is a positive correlation between x and y. Again, my dear students, positive means perfect positive, high degree of positive, moderate degree of positive, simple positive. The question is, what is the relationship between x and y in this curve? This curve emphasizes on r equal to 1. That is called perfect positive correlation between x and y. We can prove another one, model 3. Model 3, 0, O. This is O axis, 1, 10, 15, 20, 25, 30, 5, 10, 15, 20, 25, 30, 5, 10, 15, 20, 25, 30, 5, 10, 15, 20, 25, 30, y-axis. Look, when x is 30, that is 30, y is 25. Y is, this one. When x is 10, y is 25. When x is 15, y is 20, that is 20. When x is 20, y is 15. This way, we have another line. This line is downward. This means there is a negative correlation between x and y through scatter diagram. And you can explain r equal to -1 because all the dots mixed in the same line. This is called, there is a perfect negative correlation between x and y. This is a scatter diagram, and you can say it the graphical presentation of the relationship. So my dear student, I hope you better understand what is a scatter diagram and how can you draw a scatter diagram from the given data in your question. In B part, in different examination of National University, this question was important. Now, the mathematical term, Pearson's coefficient of correlation. The relationship between two variables has been designed mathematically or numerically by the statisticians Pearson. With the honor of his name, this method known as Pearson's coefficient of correlation or Pearsonian correlation coefficient. Dear students, Pearson's coefficient correlation can be determined in three methods. Number one, by using actual data, by using actual mean, by using assumed mean. Most of the cases we can use this actual data to find the relationship between two variables considering Pearson's coefficient of correlation. Let's see, by scatter diagram we have r equal to 1. Let's prove it in mathematical term by using Pearson's coefficient of correlation. X, y, x square, y square, xy. This is the prescribed table for determining Pearson's coefficient of correlation. You can write here Pearson's coefficient of correlation, or you can write table for calculation. Let's see, x 10, 15, 20, 25 and 30. Y 5, 10, 15, 20, 25. So square 10, 100, 15, 2 to 5, 20, 400, 25, 625, 3, 900. Again 5, 25, 10, 100, 15, 2 to 5, 20, 400, 25, 6 to 5. XY 50, 150, 300, 500 and 750. I am not using calculator, so it may be wrong. Just justify by your own calculator. $25 plus 20 plus 25 plus 30. Summation x equal to 100. Again 30, 50, 75. Summation y equal to 75. 325 plus 400 plus 625 plus 900. Summation x square equal to 2250. 125 plus 225 plus 400 plus 625. Summation y square equal to 1375. Finally 200 plus 300 plus 500 plus 750. summation xy equal to 1750. So my dear student, let's see the formula for determining Karl-Pearson's coefficient of correlation. We know that Karl-Pearson's coefficient of correlation is R equal to summation xy minus summation x into summation y by n divided by root over summation x square minus summation x by n whole square, or summation y square minus summation y whole square by n whole square by n. This is the formula for determining Karl-Pearson's coefficient of correlation by using actual data. Dear students, look, the formula for determining the correlation between x and y provided by Karl-Pearson's formula is xy minus summation x into summation y by n divided by root over summation x square minus summation x square by n, summation x square by n, again summation y square minus summation y square by n. Data provided by the table applying in the formula, look, summation xy 1750 minus summation x 100, summation y 75, and number of observation is 5, 1, 2, 3, 4, 5, so n equal to 5, and summation x square is 2250 here, and summation x 100 square divided by 5, and you know how to use the formula with the data from table. And finally we have found the value r equal to 1. Remember, in scatter diagram we have the same value r equal to 1, and with the mathematical term this is also found that r equal to 1. So whatever the method, result will be same. This is the statistical philosophy. So dear students, what we have learned from the value, that is r equal to 1. R equal to 1 represents that there is a perfect positive correlation between x and y. X, look, is changing in same direction, and also y is changing the same direction. So ordinarily we can say the change pattern is same, so why should not r equal to 1? And we also know the explanation of a result. The result is 1, and the explanation is, since r equal to 1, the relationship between two variables, that is x and y, is perfectly positive. But when you solve this problem, model 3, I'm sure r equal to -1. When you solve this problem, this result will be r equal to 1. Just try yourself in your home with the help of the table and with the help of the method. Dear students, r equal to -1 means there is a perfect negative correlation between two variables. For example, if x move right, y will move left. There is no relationship. And finally another relationship we have, r equal to 0. R equal to 0 means there is no correlation between two variables. They are independent, no relationship associated with the two variables. But dear students, you know, you don't have got the result always 1 or -1 or 0. You may have r equal to 0.90, r equal to 0.80, r equal to minus 0.80. What does it mean? How can we explain the relationship if the r equal to 0.90, r equal to 0.80, r equal to minus 0.80, r equal to 0.50, and whatever result you find from your calculation technique. Let me introduce you. R equal to 90 means there is a very high degree, not perfect, less than perfect, but there is very high degree of positive correlation between two variables. R equal to 0.80, it also emphasizes on there is a very high degree of positive correlation between two variables. But if you have r equal to 0.50 by 0.50, this is a moderate correlation relationship. There is a moderate degree of correlation between two variables. And r equal to 0.7, you can say there is a high degree, not very high degree, there is a high degree of positive correlation. So dear students, you can learn from this lecture, and using the formula mentioned in the board, you can calculate in your home. And finally, Spearman's rank correlation coefficient. This is another correlation between two variables, and I don't have enough time to perform these topics. Inshallah, in my next class, I will conduct I will try my level best to show you the relationship between two variables according to Spearman's. So far, stay home, stay blessed. Thank you very much.